For your first experiment, you take a pendulum. This pendulum here consists of a marble on the end of a string. You can use any small object, tie a thread around it, and construct yourself a pendulum. Now, the object should be spherical or nearly spherical, so you can measure the length of the pendulum by measuring the distance from where you clamp it up here to the center of the object. Because we're going to study the length of the pendulum as a function of, we're going to study the frequency of the pendulum, or alternatively the period of the pendulum, as a function of its length. So the procedure is very simple. You clamp a pendulum between two fingernails, and then you let it oscillate. And at some point you look at your watch or clock and you start counting oscillations. Okay, we'll start right now. 1, 2, 3, 4, 5, 6, 7, 8, and so forth. If I count these oscillations, an oscillation consists of 1, 2, 3, and so forth. If I count these oscillations for about a minute, I can get a pretty accurate count. I'll get the data that allows me to determine pretty accurately how long it takes the pendulum to make a complete oscillation. Then I simply measure the length of the pendulum, and I want to measure that in centimeters. Now I'm going to measure that length from the center of the sphere to where I clamped it. Turns out this one's very close to 20 centimeters. Okay, we see the length there. So I can write down my data. Now when I write down data, I want to write down exactly what I observed. That for a pendulum of length 20 centimeters, I counted, let's say, 87 oscillations in a minute. Or if you're counting for 30 seconds, whatever you count for 30 seconds. And I don't think it's 87 oscillations, but you're going to measure that. That's your data. You write down that data, and you're going to report that data to me. You always do this in labs. You always report data directly. Later on, you can do analysis with the data. You can do arithmetic with the data. You can take your data and do different things with it, but you always report the raw data. Otherwise, I have no way of verifying that you've done things correctly, helping you determine what your errors might have been. Now, we can change the length, and of course that's going to change the period of the oscillation. Now when you do this, you want to be careful not to move your fingers. Now, your fingers are inevitably going to move a little bit. Notice I'm kind of supporting the thumb of my right hand with the index finger of my left hand to try to keep things as stationary as possible, because if you move your fingers a little bit, you can actually have a little bit of effect on the period of the pendulum, and that's not what we want to do. So the experiment is going to be to then count the number of cycles in, let's say, a minute at another length, and then we measure the length of the pendulum. That one looks to be about 28.5 centimeters. Okay. We do this for a variety of different lengths so that we can see how the length of the pendulum affects the time required for one complete oscillation. Having done that, we're going to be able to use a pendulum as a pretty accurate timer.